Welcome to Lecture 4, Implementation. This is the third element in our innovation process that we're going to put together. So we covered technology, market application, which we refer to as market, and now implementation. So implementation is the one that everybody forgets because I think even the casual person that comes across technology and commercialization understands market and technology, although typically defined differently than we have, and our graphical representation is very important, and that's going to matter as we come to putting our model together. But in understanding how to think about and how people do innovation, this third category that we're going to talk about in Lecture 4, implementation, is really important. And it involves all the stuff that typically people put into the black art part of innovation. It's really connecting market to technology, and you'll see that it is the key piece for really an innovation process that can explain a few examples that have been very important in our marketplace. And without an implementation part of your model, you just can't describe what goes on. So with this last element, we'll then be able to, in Lecture 5, start talking about putting all these elements together into our full innovation picture. This is Lecture 4.1, the first lecture in the two-part series for implementation. Implementation, as I mentioned in the intro, is a little bit different from market and technology, which are a little bit easier to understand, and so we left implementation for last. But hopefully from this lecture and the next one, you'll be able to see how important implementation is, and we give an important example. So in fact, this lecture is to make definitions, what is implementation, and also give you the example of Taiwan Semiconductor Manufacturing Company, which is TSMC. So as with the other elements, our third and last element of innovation, implementation, has a definition. And I'll read it again like I did the others in the other lectures. Implementation includes all that must happen between technology and market to connect the two. It encompasses everything required to make the innovation functional in reality, from the forms and methods of production and distribution in the context of industry structure, intellectual property, business model, etc. So there's a lot in here, actually. So let's stop and look at this again, as we've done with the other cases. So the way to think about the connection between the two is that in a very simple way, you might say, okay, here's this technology that I have, and I want to directly inject it into this application. So we've already introduced the idea that we want to have uncertainty, that you can't really pick one particular application, and we'll get into why great innovation requires uncertainty in these categories. But at least, for now, let's imagine the case where we do very incremental innovation, and we'll talk about incremental versus fundamental, but very incremental one where we have an exact application vision and a technology we're trying to put into it, a very specific technology we're trying to put into it. Then, if you think about what that requires, we have to have things like manufacturing. We have to have things like distribution. We have to have sort of our role in the industry. And what I mean by that is, for example, we have suppliers that are going to make things for us. We put something together, and then we have customers. So either it's an end customer, or, like I've been saying before, it could be an organization. We could be in the middle of a supply chain where we get stuff supplied into us, and then, so if I'm going to give the example of a materials company, I would get raw materials, I would make a material, then I would sell it into somebody that makes it into a device, for example. And so this here depends on, structure of the industry, right? So, uh, and then another example is protection of intellectual property, which is referred to typically as IP, right? Um, and in our role in the industry, when you think about suppliers, customer, and how you extract value, that's your business model. That's what people refer to as a business model. In other words, are you selling a particular thing to somebody and you've inserted yourself in that supply chain? Your business model is, that, and you get, X amount of profit out, or is it that you do that for a while to get established, and then once established, you collect licensing from them, or whatever. So that's called a business model. So all these things, like I said, are typically grouped into the black art of innovation, and also, by the way, entrepreneurship. And the truth is that they're all in implementation. It's what you need to do to connect technology, to market. And that's why we wrote down here really everything to make the innovation functional, in reality. So production, distribution, industry structure, like I mentioned up here, intellectual property, business model, all the stuff I mentioned there. So that's a quick introduction to implementation. It's one that requires more of an example, and I'll show you the important example in a little bit. Just like technology and markets, things don't stay stationary in the world, even though we all want security and want to believe that's true. Actually, there's always new methods of implementation occurring, even though just like methods of more and more technologies appearing and other ones disappearing, and same thing with market application. So the implementation space is always changing, and you can think of new ones and old ones. And here I'm just giving an example that there's old business models that can be brought back when an innovation makes it so. And and vice versa, of course. Again, we tend to think about implementation now like we thought about technology, where, I come up with a new business model that disrupts the old one. But there are derivatives of old ones and new ones. So again, going back, to this idea that, we have to think about, new and old. You can't just think about there's only a n set of business models or n set ways of doing implementation. For example, probably the one that a quick one that you guys can understand pretty easily is Microsoft. So, the business model for hardware and software in the industry was that you sold software with hardware, and people thought people that just did software were essentially consultants. That's really how it was. The idea that you could sell software by itself in the form of intellectual property, because remember, for years, and still for a lot of its products, the model for Microsoft is to sell a license. You're not actually buying the software, you're acquiring it, you as an individual are acquiring a license to use that software. So that was a business model that was created and was very novel. So that's a quick example of implementation where that was probably one of Microsoft's largest part of their innovation. So anyway, now I want to go on and talk about a physical. Microsoft is a software model, but let's talk in some detail about the TSMC example. And this takes a little bit of background to understand, where the semiconductor industry came from. So let me give a little background. So at the beginning of time, at the beginning when people were experimenting with different kinds of semiconductors, you would have people that would make, some silicon ingots and cut silicon wafers. So I'm drawing a wafer, that's what this is supposed to be. And, some people would, make gallium arsenide wafers, because at the beginning people didn't know silicon was going to become the dominant material. In fact, at the beginning, there was germanium was one of the most interesting ones because people could make devices that were more impressive, early on. So, and people have to play with these things, so they become, sort of at the material level. There's a lot of innovation in materials at the beginning. Now, what happens is this is followed by, the reason these materials are interesting is they feed into different kinds of devices. And so at this level, there's two things going on, processing and, device innovation. So, because, of course, I'm calling it the device level here, but don't forget you have to process these materials into these devices. And then these devices are sold into the marketplace, and they go into things initially like computers. And can't spell. But computers weren't around for a while, so there's all sorts of other devices, radios, whatever that these things went into. And what happens is eventually there's so many applications up here that it starts to create a lot of demand for a particular kind of device, which was related to silicon electronic devices. They actually changed over time, but then that drove a particular material quite a bit. So let's fast forward to where silicon is really taking off, because why? There's a lot of end customers here that are pulling it up. Okay. Now, the way that the company started to form then was that actually, if you really needed to coordinate this over a large number of different kinds of companies, then it'd be kind of tough at the beginning because one person doesn't know what the other one's doing, right? So what you find out is at the beginning of industries, typically you have vertical integration. And what that means is that within one company, you make the material, which is a key added value when people don't have that expertise. When this is occurring, all this is new and people start to make devices and wow, we have customers. And so all of this is kind of, uniquely in this company for a while because this expertise is not known widely. And so we have an integrated thing where, these things are processed and then they go into some device. And then after a while, another invention, the integrated circuit, and then of course things like computers. So over time, this becomes a vertical industry. But then a funny thing starts to happen is that when the industry grows large enough, you tend to go away from vertical integration because the knowledge becomes widely known. So in reality, there may have been a few companies that vertically integrated the computer, but really what happened was we had a lot of integrated circuit companies at the beginning. So what happened was you ended up with a lot of folks vertically integrated through here. So let's jump to my next. Let's jump to a next example where now we're going to have many of these integrated circuit companies. Oops, sorry about that. Oops, going the wrong way. TSMC example. So now we have, let's say, 5, and I'm not going to draw them all, but let's say we have 5 vertically integrated companies now, and they're doing their own materials, their own devices. I'm simplifying this again, processing and devices, and then their own integrated circuits. And, that's happening for, all these guys, right? All right. So we've got 5 of these, and all of a sudden, an enterprising young materials person comes along and realizes that this company has V1, volume 1, this company has V2, but the truth is that V1, they're on the same order of each other. Let's say they could be off by factors of 2 or something like that, but their volumes are, and this is of course why it takes a great number up here to develop before this makes sense. But I got 5 to 10. An enterprising young man comes or woman comes along and says, "Aha! What I'm going to do is that I am going to focus on making this lowest level for everyone." Now, in this particular case, and in a lot of cases, it starts at the bottom of the food chain. So why is that? One is it's the lowest value. Remember that these materials are made as they go up the food chain. They acquire value because of the processing put into them. So it's the lowest sort of value in the chain. Second is that because of the huge demand up here, what's happened is all those demand for silicon integrated circuits have matured a lot of the silicon device, but in particular, it's matured the material even further, because you can imagine how the material has to be really, really reliable, and costs have to come down, and all these sorts of things as this whole thing drives. So it starts at the bottom because of those reasons, and some enterprising person comes along and says, all right, we have something that's called the volume cost curve. This, as we all know, as there's more and more made of something, it becomes cheaper. And so the reason for this is that when you build a factory or you build something, anything, to any kind of infrastructure or human capital to address a market, it costs you something, and you have to, those people and the machines they run, everything else, are a fixed cost basically, because you lose too much information if you're constantly exchanging people. And of course, in the case of infrastructure, buildings are there, and so there's this fixed cost. So initially, whatever your volume is, you divide that fixed cost over the number of things you sell. Well, if you sell more and more and more, you don't have to expand your fixed costs that much. That is, your manufacturing facility can get more and more efficient, and your people get more and more productive because they learn more. You can imagine that your volume can go up, but your fixed costs don't really keep up. In fact, that's a good industry, because that's kind of how it's supposed to be, where your volume can go up more easily after some period of time, and your productivity's going up higher. There's an increase in productivity, in other words. And so what that means is that you have a volume cost curve where the more stuff you make, the lower the cost. So the enterprising person comes along and says, aha, these guys here are at V1 and V2, whereas if I get all 5 of them together, or 10, or how many, and I supply it to all of them, or half of them, whatever it is, that's why you need, again, high volume. Let's call this V large. Then my costs are lower than theirs, and because it's becoming a standardized product, my product, I'll of course have the same thing. In fact, it'll be probably better in a lot of ways, but also it'll always be lower cost. And so this person starts to disaggregate the industry. So what happens is now you have this materials company, and its goal is to do horizontal integration. So its goal is, in a way, to go to higher and higher volume to supply more and more of these guys. And so now, I'm not drawing it to scale here, but I have many of these companies, etc. Etc. And now they can concentrate all of their intellectual property and productivity on device and IC. They don't have to worry about materials anymore, and they can get rid of those fixed costs. Now, this only happens, of course, when there's a very successful growing industry that's large enough. And so in the case of silicon, that happened. Now, of course, it's only some matter of time. And in the book, Inside Real Innovation, we cover this in more detail. But there's an enterprising person named Morris Chang who, working at TI, noticed that there were more designs that in the IC space you could be growing faster if there was more access to these factories. So, of course, the second level started to become disaggregated, where he said, I'll make a manufacturing facility, a wafer processing, meaning that, I will take wafers, I will process into ICs. And again, it's because silicon had, with MOSFETs, had become kind of standardized, and there's like a roadmap for continued progress. And so this started what is called the Silicon Foundry business. It's a bit confusing because the materials are foundries for wafers, but this foundry part is sort of a foundry for integrated circuits, right? But the way the terminology has evolved is that it's called the Silicon Foundry. So you can read the whole story of an abbreviated story of Morris Chang inside the book, and it's also available, of course, online. But the bottom line is this created and still is the largest and most successful foundry so far, called TSMC, Taiwan Semiconductor Manufacturing Company, and of course a lot of benefit to Taiwan occurred by creating this model inside that country. So what this did was then disaggregated the industry into the last part, which is, of course, now you have the, you might have heard of the fabless, chip industry. And so these guys, they actually sell integrated circuits. They design them, but they actually don't have the manufacturing facility, and they don't make the wafers. So this evolution in each case, like in the materials case, and then in the case of Morris Chang, taking the processing part out of the integrated circuit company, these are all examples of implementation innovation, because notice how the technology is largely the same. There are some differences now starting to appear, but in general, it's because the technology was becoming somewhat standardized that this was possible, and they helped standardize it even more. And so that's why it's not really new technology, and it's not a new market either. I mean, it is in the sense that they made a market for their services, but if we look at this original, there's no new market application that's being created there yet. I mean, of course, later on there's new applications that these guys come up with, but that's their business anyway. So really the key is a very important example of implementation, where if you just look at technology and market, people leave TSMC off the map because they're kind of like, yeah, they were really successful. They became this gigantic industry, but I don't really understand them. Well, the reason they don't understand them is they're not properly thinking about innovation and one of the most important parts, which is implementation.